Good afternoon. You can hear me at the back. Excellent. Good. Okay. My name's Iain Bray. I'm a senior sales engineer. First of all, a couple of things. I didn't come up with the title. I'm just volunteered to talk to it. Okay. Let's have a look at the agenda. Okay. Quick show of hands. Maybe, by the way, warning, there may be some audience participation, which is why normally people sit at the back, but don't worry. Who has any idea what sharding is? InterSystems people don't count. Okay. A few, right, okay. The idea of this particular session is just to give you an insight into the basics of sharding, what it is, how it works, where it can help, and so on. So we're going to be looking at what exactly is sharding, what's it good for. I mean, I wouldn't say it's bad for anything, but there are areas where it's better than other things. Let's keep it simple. I mean, you've heard a lot already today about how we strive, not just in terms of performance and reliability, but also to try to remove the pain from what you have to do so that we do it for you. It's all under the covers somewhere. How to make it go even faster than it should do already. This is probably one of the few sessions where you get a live demo of the product. This demo's been working for the past 3 weeks, but if you've ever done a live demo, you know what happens next. Keep your fingers crossed. And then FAQs and summary and questions, and you might even get some answers when you've asked the question. I'm encouraged to ask you, if you want to ask a question, to go to the microphone. All these sessions are being recorded, so if you ask your questions through the microphone, then they'll be recorded as well. If you don't feel like getting up to the microphone, I will try to repeat your question so that it goes through onto the recording. If you have any other questions as we're going through, please ask. I don't want you to kind of think, what was he talking about? And then 2 slides further on, you're just even more confused. So, what is sharding? Actually, sharding as a concept is relatively simple. It's a way of horizontally scaling so you put all your data across multiple nodes. Where the data actually goes on the nodes is abstract to you. You don't care, your application doesn't care, but it's spread out over a number of nodes. Very useful for when you've got lots of data and so on and so forth. So you'll also have heard us say about sharding that at the moment, sharding is only really for SQL. Next year, we will be introducing sharding with objects and with MDX and so on, but at the moment, we're just talking about SQL. So we'll talk about tables and rows and things. Okay. But you have multiple nodes, and you spread the data for one particular table over as many nodes as you have or you want. It's an example of what we call horizontal scaling, which is to say that the more data and the more resources you need, you scale it horizontally, you add more nodes. The other form of scaling would be vertical scaling, where you increase the power of a single node as opposed to adding more nodes. Both are okay, both have their uses. It's horses for courses. It depends on how you're going to do it for your particular solution. So when you're looking at scaling, and particularly with vertical, you've got to understand that when you're adding CPU and RAM in terms of vertical scaling, it gets exponentially more expensive the more you add to it, generally. Then, of course, you're going to mirror it. You're going to have high availability. Before you know it, you've got an awful lot of money, but it may be the way your solution works best. So horizontal scaling might not be for everybody, but as an option, it's there for you to look at. Let me give you an analogy. You can have vertical scaling, which is a fast forward, or you can have horizontal scaling, which is a number of not quite so fast forwards. Okay, so far so good. However, as the system grows and more data comes in, more users come in and so on, you find that actually your fast forward isn't capable of actually doing the job that you expect it for. So you get rid of the fast forward and you buy a Porsche. But if you're horizontally scaling, what you do is you add a few more fast forwards into the mix and keep going. If you've got a really successful solution and application and you're getting lots more data, lots more users, eventually even the Porsche is not going to keep up. This is where the audience participation comes in. Guess the next car. If it was me, it would be. So you dump the Porsche and get a Ferrari. It happens to be red, so it matches the color scheme. So, or you could buy more cheap Fords, but that's the analogy. You either keep vertically scaling up in terms of power and cost, or you horizontally scale in terms of adding more and more relatively cheap nodes into the mix. But the whole concept is that if you don't know how big your system's going to become over the next few years, you don't need to buy a Ferrari or a Porsche on day one. You can start off with one or two reasonable boxes and then slowly grow the system as time goes past. Okay? So what is sharding actually good for? Well, if you have an awful lot of data, a huge amount of data coming into the system, and you need to spread it out over a number of systems, that's one of the areas. Excuse me. If you've got high volume, high speed data insertion, where you're getting all these constant, relatively small feeds maybe, that's another area you may want to look at sharding. If you're using a lot of queries, then again, look at sharding. Now, as we've said here, actually, scanning a whole lot of data to return a small amount is going to give you a bigger benefit than scanning a relatively large number of data, number of rows to get a small amount back. So reading 100,000 to get 20 rows is the kind of sweet spot you might be looking for. You don't need to shard all your data. You only need to shard the data that matches certain criteria as far as your system is concerned. So you're looking at the overall size of the data, how many inserts, what kind of queries, as we've said. And also, if those queries are using aggregates or they're using joins, that kind of complex query, then sharding is a good way to go. And there's a nice little table. Actually, you'll find this table on the learning services where you're looking at sharding. I'd recommend everyone to go and look at the learning services if they haven't, because this is the kind of questions we get asked about sharding and the answers that we can look at. But you know, if you're looking at joins, if you look at complex queries, lots of data coming in, because don't forget, with all those data nodes that you have, all those cheap Fords, they can each act independently and they can all do work. So you're spreading the stress over a number of nodes rather than just one. You don't need to shard everything. Some systems, when we're talking about sharding, will actually require that all your data is sharded. But in the case of InterSystems IRIS, you just shard what you need to. Leave the other tables alone. Anybody here actually using cache with ECP? Oh, good, a few, right. So in terms of ECP, the Enterprise Cache Protocol, you're sharing data across. And when we talked about simplicity, when you're setting up the system, the ECP is automatically built in so that you'll be able to share the data over as many nodes as you have, and it's completely invisible to your application. We've always concentrated on performance, on reliability, and simplicity. If it's a simple architecture, it's going to be more robust. If it's easy to set up, you can spend your time doing what you're good at, which is your application, and not having to spend weeks trying to set up a complex system. So we'll take the heavy lift and do everything else that's required underneath. And there are a certain number of tools that go in to make your life easier. You can just add nodes. as you go along. All the data on all the nodes is accessible to all the clients. And what we need is out-of-the-box efficiency. And we'll look at some performance data later in terms of comparing, comparing InterSystems IRIS to a unnamed competitor to show you how it works. Okay. So, day one. Remembering that you don't know how big your system's going to get, start with one node. You can always add more later, but there's your client with the one data node. It's a shard, but it's a shard of one. As the system grows, you can add more shards. The data will spread across the shards. And in fact, for smart tools, and if you've been to any of the machine learning or artificial intelligence, you'll have seen us talking about Apache Spark and various things. But we're smart enough so that they can automatically parallelize across all the systems to try and get the information out. The schema is shared across. You don't need to do anything, as is the code and the data. Yes, it can be mirrored. It's just an InterSystems IRIS instance. There's nothing particularly special about that. So it's an instance, it can be mirrored, which means you get the high availability. Yes, it can be a VM. Yes, it can be a container. That part should scare most people. Anybody got containers? Oh, yeah, congratulations. Well done. Everybody else tries not to. So let's look at a little bit at the architecture. So far, we've got data nodes. And what the data nodes are doing is they're storing the data, but they're also processing the data. They're taking in the data ingestion and putting new data into the system. They're handling the queries that come in, so they're querying the data and sending it back. If you're noticing a conflict here, it's because you're querying data that's being updated, and if you're used to cache buffering and all kinds of things, that can get wiped. So you can have a different type of shard called a compute node. And what a compute node does is you can only join it onto one data node, but you can have as many compute nodes as you like to each data node. And it's the one that will handle all the queries, it will do the processing, it will cache the data from the data node into itself, and therefore improves the performance of the system. Obviously, if you're speccing the machines, what you're looking at here are more CPU, whereas down here you're looking at more I/O. So you've not just got a cheap Ford, you've now got a cheap Ford with a bigger engine and fewer seats. What we've done, though, is we've been clever enough to know that any updates come directly into the data nodes and avoid the compute nodes, which means that we don't disturb the caching on here, it only disturbs it on here. And obviously, if you're updating a cache that's in use on a compute node, that will be automatically refreshed, but you're not constantly asking the machine to update all its buffers. So it's speeding up query times. We're not the only people to do this. Other people do it. There were some well-known products out, times 10, Redis from Redis Labs, and so on and so forth. But they are third-party add-on systems. This is all InterSystems IRIS. It's all our own stuff. The maintenance, the debugging, it's all one homogeneous system, which means your total cost of ownership is all with us, making it simpler. The setup is simpler. The maintenance is simpler. OK, now we get to the exciting bit. What I'm going to try and do here is we're going to bring up InterSystems IRIS. It's a fairly blank installation. There's not much on it. We're going to add a couple of shards. We're going to put some data into it. When we say we, I mean me. And then see how it's spread across the shards. What we'll then do is we'll add a third shard, and then we'll show how to rebalance the data that already exists across those shards. Okay. You also get to discover how bad my typing is. So let's see if we can. Right, okay. So let's go to System Administration, Configuration, Namespaces. And you can see we've got one on here, User, nothing else. Like I said, it's a fairly blank installation. So we're going to create a new namespace. Okay. Yeah. Make the routines the same. Where are we? Shard 1. Okay, we don't want the integration stuff because this will speed it up. And save. Okay, so we now have a new namespace called Shard 1. Repeat the process. Okay, so 2 new namespaces. Now, in the ideal world of sharding, those would be on other machines. Obviously, for a demo, it's on the same laptop. Next, what we need to do is we need to set up the sharding. So back to configuration, and we'll go to the sharding configuration, and effectively our master namespace, the one in which we'll be controlling where the data actually sits, is going to be user. So we're going to assign a shard, and go host in this case, 51773, shard 1, and it's a data shard. We could pick a compute instead. Okay, finish. And do the other one. Five one double 773. Okay, and we'll just verify that to make sure it's okay. You can see the machines and such like. Fine. Okay. If we look in here, we'll see that at the moment there aren't any sharded tables. We haven't done anything. Okay? It's just the system sat there with 2 shards on it. So let's go and create a table. And Explorer, SQL, and down here. Okay. Fairly simple table. We've got SSN, social security number, there's a primary key, name, date of birth, and then we've said shard key is on SSN. Okay, so the data will be split by the social security number across the particular shards that we're using. And if we then execute that, worked, great. Okay, excuse me. So I actually have a class here which I'm going to compile, but effectively it just takes in a number and generates random names, dates of birth, and so on and so forth, and inserts them into the database. Just to prove that we haven't done anything quite yet, if we go back to system admin config sharding, and we look at sharded tables, we now have the sharded table in there, but there's nothing in it. This is not smoke and mirrors, this is actually real. Well, about as real as a demo. So back to here, we'll compile this. Okay, done. Right. Do class, oops. And we'll put 5,000 people in. So what the system is now is inserting 5,000 people into the sharded table, which means the algorithms kick in, they find out what the social security number is and go, it's going over there or there entirely. Great. 5,000 people in. Let's go back to here and ask for the details again. Oh, okay. Data spread across 2 shards. And if we did a query on that, we'd get to see everything. So, System, Explorer, SQL, yeah. Select, count, everything from demo, person, over here. 5,000, and just to prove it, if we actually changed away from user and picked one of the shards, and put that in again, we still get 5,000. So the data is available to all the nodes on the system, whether it's user here in effectively what we might call the master, or it's out there on the shards. Right, so let's create a third one. Admin, config, here we go, namespaces. I'll type as quick as I can. Shard 3. 3. Next. Finish. Shard 3. Take that off. Yeah. Go. Okay, so far so good. Config. Sharding configuration. Assign a shard. Oops. Wrong one. User. Assign a shard. Okay. Machine address. Port. Namespace. And verify. So far, so good. Right, sharded tables. There's the data. Sorry, there's the table. We put the data in, and at the moment, there isn't anything in shard number 3. Right, now for the clever bit. Okay. We are going to rebalance the data over the shards. We've got data in 2 shards. We now have 3 shards, so let's copy it. Now, I'm going to do it in real time here because it's a demo and I've only got 5,000 patients anyway. That's why 5,000 people. You can schedule this. So you could have it running for a certain amount of time at a certain point in the day. So you might say between midnight and 1 o'clock, I want it to do this. Okay? If we look at what it does, it moves things in buckets. Now, we haven't got it yet, but what we're looking at doing, probably next year, is that you could throttle it to say, and I only want to move X number of buckets. So you're not killing your system by trying to move everything all at once. Your queries will be completely unaffected because the data is still in wherever it happens to be. All it's doing is, over a period of time, is slowly reallocating the data across all the nodes. So now if we come back here, and ask for the details again, there we go. So it's completed, it's rebalanced the data across the systems. Okay. By the way, this is 2019. Just for anybody who happens to be running sharding on the current version, this is coming. This will be available in effect later this year. Right. This is a pre-release product that we're seeing. But the whole concept is already there. Okay? Right, just to give you a little bit more in terms of what we're doing. So, let's go back to Explorer. SQL. Let's go to here. Okay. I have another table that I'm going to add in, which is another fairly simple table. Demo.city is going to consist of the name and the state. I have another class here, which I'm going to compile, which just puts a small handful of cities into the mix. Okay. Okay, go back to here. Okay, we're in the user namespace. So far, so good. We've got 12 entries. This is not a sharded table. It's only available in one location. However, the data is available everywhere. We've put the ECP underneath. So if you're doing a join on a table where your main table is sharded, but it has to join to a table that's relatively small and is only actually in one physical location, the underlying ECP that we've put in will make sure that all the data is available everywhere to every shard. Because don't forget, if you've got something like Spark talking intelligently to each individual shard needs to have access to all the software and all the data all of the time. Did that make sense? Because a couple of people there blinked.
I mean, what if the tables aren't Spark? I mean, then you're going to be copying a whole bunch of rows. That's not practical.
You mean if the tables in one physical location aren't small, yeah, they're not being physically copied, it's only by ECP. So it's only the buffer of the page that you require. It's not a physical copy. It's available. You can do that now. Sure. You can do that now with ECP. So you can say, right, I've got data over there and I've got data over here. My namespace mapping does this. But when you run the query is executing here and not everywhere. Whereas the difference with this is that your query processing is happening on every node that has access to the data that you require. And that's in effect the big difference between ECP and sharding. Yes, sorry.
So where is the data that tracks the location of the data is? Is it like a management?
Yes. Where's the map of where the data is? Yes, in effect, because if you think about it, and again, going back to ECP, where we do the package mapping and the namespace mapping to say, this global or these globals are over there, that's in effect what we've done. It's just that we've done all that for you, so you don't have to go in and type it all in for each and every shard that you create. Did that make sense?
Yeah, but is there a particular node that's like the scheduler that processes?
In this case, yeah, if you think I've been, well, in terms of the question, is there a specific node? Yes, there is, because I've been setting this up from the user namespace. The user namespace is physically located on this instance, and therefore that's where the map and the master is. Okay?
So in our situation, we have massive tables full of PHI or PII.
Yeah.
And since this is using ECP, we wouldn't really be able to leverage that, I don't think, because it's not a secure communication. So the data in motion, do you have any way of securing data in motion between the nodes?
The question is about data in transit, in effect, and its encryption on its security. The answer is probably yes, but that would be for another session and somebody who knows what they're talking about.
See, I don't think so. Because
Yeah,
ECP's all
ECP by default
Yeah.
is.
I mean, and if you start encrypting it, it's gonna slow it down. But we'll ask, that's a
Yes.
There may be some TLS or something.
Somewhere out there's a man who knows. And I'll find a way.
Encryption is data in rest, and when you bring it to the memory, it's being encrypted.
Yeah.
So that's the old.
But across the network, that's a problem.
Yeah. All of our data has to be encrypted while in motion,
But you use different in motion, not in rest.
in motion and in rest. So, yeah, it's, being encrypted on disk is great, but it's when it goes over that ECP connection that we wouldn't be able to utilize.
But your ECP connection can be also encrypted while using SSL.
Yes.
Okay.
So that's the data in transit encryption. If anyone didn't get that, when you set up an ECP port-to-port communication, it doesn't have to be flat TCP IP. You could use TLS, in effect, which would do the encryption for you. There was a question at the back.
So, in case where we are creating a sharding table, okay, and then and the previous case, the same class is sharded to 3 different namespaces, okay? So, how the ID is basically located to each namespace? Is it like that 1 to 550 we go to sharded 1?
No, no. There's an algorithm inside that goes, you're going there, you're going there, you're going there. It doesn't do like 1 to 1,000 here and 1,001 to 2,000 here. It splits it far more irregularly.
Just split it that one will go to shard 1, 2 will go to shard 2 like that. And there is
You can go and actually have a look at what is on a specific shard if you wanted to, but otherwise it's abstract and it's not something your application needs to know about.
okay, and I still can go to the globals and see that which data is present there. If I open the terminal, I can see that.
You still see globals, yes. If you wanted to go and do a global list on a particular shard, yes, you get to do that.
So you see all the data in every namespace on that one.
If you use SQL at the moment, yes. Because if you were using a global lister at the moment, you would only get to see what's on that shard.
Okay, so the whole table is not actually.
The whole table is available if you're using SQL to get at it. If you're using objects or direct access, it's what you get to see. Wait for next year. Okay, we need to just go on. Okay, so we did some benchmarks, and there was Yahoo helpfully published a set of how to do your benchmarks, and you can go in and run standard tests against it. So we did a test against a commercially available database. I don't know what it is either, so don't ask. No, I don't, honest. And there were actually 5 different workloads, and you can see here update heavy all the way through to read, modify, write with various bits and pieces. And this was for 100 clients, where the left-hand, the green one, is InterSystems IRIS, and the right-hand, the blue one, is the competitor. So we were always significantly faster on each of those tests. Similar, same kind of workloads, but showing different number of concurrent clients. In this case, it's looking at how much faster InterSystems IRIS is compared to the competitor, and the slowest was we were just less than 1.5 times quicker than the competitive database. So we're getting good performance, and if you're thinking about it, this is fairly early days with sharding. Some frequently asked questions. If you were in the session with Andreas Dico, he talked about licenses, but there were 2 different types. There's a server license or an enterprise license. If you have a server license, you need to buy enough license to cover all the cores in all the shards. Otherwise, if you're buying a concurrent user license, it's cover your concurrent users, and we don't actually mind how many different shards and nodes you have. Can you run different versions of InterSystems IRIS? No, not yet. Wait for next year. Practically, of course, we can't really say you're going to have to update your entire system like that. It's got to be a rolling update, so we're getting there, and that will again be at some point next year, we hope. Can the shards be mirrored? Yes, and yes, they can run in VMs. Yes, they can run in containers. They're all there. Can you use different operating systems across your enterprise? Yes. As long as at the moment it's the same version of InterSystems IRIS, we don't mind. Yes?
I'm just getting familiar with this, but with cache, is sharding possible to be done with cache?
No.
It's not.
You cannot do sharding with cache. If you want to do sharding, it has to be InterSystems IRIS. Yeah, because all the algorithms for where the data goes, all the parallel queries and everything else is in InterSystems IRIS and not cache. Okay, so as far as the technology is concerned, a shard is effectively a namespace on a different machine. Okay. It might not be for everybody, but if you've got a large amount of data, complex queries, lots of data coming in, look at the possibility of using sharding, because it could be useful. There are tools available that we can supply to help you with the setup. There's the InterSystems Cloud Manager. If you haven't been yet to the session on that, I recommend that you go. Make sure you take a coffee with you. It's kind of mind-blowing to begin with. There's also a sharding API. But what it does give you is it gives you a complete homogeneous environment, everything you need in terms of data nodes, compute nodes, and we try our best to do everything for you. Sharding is seen as complex by lots of people, particularly our competitors. We're doing our best to make it simpler. Even if you look up sharding on Wikipedia, it says it's complex. As you could see, okay, that was a small demo. It's not that difficult, and it will get better. Okay. We've gone to some lengths to try and make it easier. You saw most of that in the demo, dynamically move the nodes, move the data across the nodes. Given the fact I had a very cheesy title in terms of getting sharded, well, another colleague suggested it's not hard with InterSystems IRIS. We are seeing great performance from the early days in reliability, and we put everything into this. We've been doing databases for 40 years, so we've had a really good hit the ground running with this, but there's more to come, particularly with objects, with MDX, and with better performance. Any more questions? Do you want to come and use the mic, or do you want to just talk? The question is about how do we count the users, and which user is actually executing the query on the other shards. When your client runs a query on the system, it's that client that's running it. The fact that underneath the covers and invisible to you, we spread that query out over separate machines doesn't mean anything to you. However, what we do is we obviously take with it the properties of your user. So credentials and such like would be built into it. So your access to the rows and columns would be the same.
So the user doesn't have to actually exist on the other side?
No. No, you do not need to have a copy of all the users over all the shards, because that's all handled. Is it similar to subscript level mapping on cache? Yes, but the difference is that having done the mapping to get the data out to the different systems, those systems are then processing the data instead of just feeding it back to an application server. So we're making use of all the underlying technology that's been there for years and putting it to good use. Will there be an ODBC driver as opposed to a JDBC driver? I would say yes, but it will be next year, along with all the other improvements we're doing. At the moment, it's effectively embedded SQL, which you saw from the system management portal, or it's JDBC coming from various sources. But yeah, ODBC would be on the list somewhere. Okay. In that case, can I just bring your attention to these. Some of these sessions have already been run. They're all being recorded. They will all be useful if you want to have a look at them and see what they're saying, because they're all related to what you've heard here over the past 45 minutes. If you haven't been already, go and have a look at learning.intersystems.com. And who uses the community developer posing questions? Oh, brilliant. Did you ever get answers? Good, even better. Thank you very much for your time. And I realize it's now 4:45. There's only one more session to go, so thank you for staying awake as well.